All right, let's talk about something we use literally every second of every day, but maybe don't think about too much: computer networks. We're going to break down all the different types, these invisible webs that connect our entire world.
You ever stop to think about how that fitness tracker on your wrist talks to your phone? Or how that connects to your Wi-Fi, which then lets you video chat with someone on the other side of the planet? It's all networks, right? But how do they all connect? Well, that's what we're going to do. We're going to take a journey, starting with the network that's practically on your skin, and scale all the way up to the one that covers the globe.
Okay, so let's start small. And I mean really small. We're talking about the networks that are right in your personal bubble, or even closer. First up is something called a body area network, or BAN for short. And yeah, it's exactly what it sounds like. This is technology that's designed to work literally on you, or even inside your body. Sounds a little sci-fi, I know, but trust me, it's very real and it's already out there.
So a band's entire world is just you. It covers your body. Think about it, a pro athlete covered in sensors, tracking every bit of their performance in real time. Or maybe a smart medical implant that's constantly sending your vitals straight to your doctor. That's a band in action. It's a huge deal for health monitoring and a lot of advanced medical stuff. Okay, so let's take just one step out from our body and into our immediate personal space. This is where you find the Personal Area Network, or PAN. This is all about getting the gadgets in your little tech bubble to talk to each other. We're talking a tiny coverage area, just a few meters. But this is the network you use all the time. It's that invisible string of Bluetooth connecting your phone to your headphones, right? Or your laptop to your wireless mouse. It's that simple, seamless connection that just makes all your personal tech play nice together. All right, so we've covered our personal space. Now it's time to zoom out a bit. Let's look at the networks that connect entire buildings, the places where we live, work, and learn. And now we get to a term that I bet you've heard before, the Local Area Network, or LAN. This is kind of the workhorse of the network world. It's what connects all the devices in a single office, or a school, or, your entire house. Yep, your home Wi-Fi? That's a LAN. So why do we use these? Well, for one, they're fast and they're secure. Think about being in an office. It's way, way faster to shoot a huge file over to your coworker or to a printer using the local network than it is to send it all the way out to the internet and then have it come all the way back. Okay, so what happens when you've got a bunch of buildings and each one has its own LAN, but you need them all to talk to each other? Well, that's where a campus area network, or a CAN, comes in. It's basically a network of networks. Its whole job is to link all those separate LANs together. A university campus is the perfect example. The CAN is the magic that gives you that high-speed connection no matter which building you're in. It connects the LAN in the library to the one in the science building, to the ones in all the dorms. It turns all those isolated networks into one big, seamless campus network. Okay, let's recap. We've gone from the body to the building to the campus. You know what's next, right? It's time to zoom out even further. We're talking cities now, and then the whole world. So now we're scaling up to the city level. This is the Metropolitan Area Network, or MAN. And just like the name says, this network is built to cover a whole city, giving you high-speed connections on a much, much bigger scale than just a campus. A perfect example of a MAN in the wild? Your city's cable TV network. That same network often provides high-speed internet across the whole area. It's basically part of the digital skeleton of a modern city, you know? It's the bridge between all those smaller local networks and the big global internet. And that brings us to the final boss, the biggest network of them all, the Wide Area Network, or WAN. We're talking about networks that can stretch across massive areas, connecting cities, countries, even entire continents. And here's the thing, you use the most famous WAN on the planet every single day. You guessed it, the internet. The internet is the ultimate WAN. It's this gigantic global web of networks that connects billions and billions of devices all over the world. It's what makes all our modern communication and remote work, well, work. So there you have it. We've watched these networks just scale up and up, right? From the size of a person all the way to a network that wraps around the entire planet. Thinking about them in terms of size, from smallest to biggest, is a really great way to get a handle on them. But wait a second. Is size the whole story? It's a clean way to organize them for sure, but is that all there is to it? Nope, not even close. There's another really important way to think about networks, and it's all about how they work. So let's switch gears.
Forget about size for a minute and let's talk about function, how they're built. The source material points out two main architectures here. You've got your client-server model, and then you have peer-to-peer.
Okay, so on one hand, you've got client-server. This is the classic centralized model. Your computer, the client, asks for something like a website from a big, powerful computer, the server. The server finds it and sends it back. Pretty much the whole web works like this. But then you've got peer-to-peer, or P2P. This is completely different. It's decentralized. Every computer on the network is an equal, a peer. They can all be a client and a server. The best example? File sharing stuff like BitTorrent, where you're not downloading from one central place, you're grabbing little pieces of a file from tons of other users at the same time.
So you see, it's not just about how big a network is, it's also about how it's structured. Are you talking to a central server or are you talking to your peers? It's these systems, from our bodies all the way up to the globe, that are really the backbone of, well, everything we do now.
All right, let's do a super quick lightning round of the sizes we covered just to lock it in. From smallest to biggest, we've got BAN, PAN, LAN, CAN, MAN, and WAN. Body, personal, local, campus, metro, and wide. Each one is a crucial link in the chain that keeps us all connected.
And that really makes you think, doesn't it? We've built these incredible networks for our bodies, our homes, our cities, and the entire planet. So as our world just keeps getting smarter and more connected, what's next? What new kinds of networks are we even going to invent? Pretty wild to think about. Thanks for tuning in.